Resolving software compatibility issues. Here we pick up the torch from what we covered in the previous nugget with hardware compatibility issues, this time looking at the underlying operating system. I'm going to show you basic troubleshooting strategies that are common to all major operating systems, as well as those that are specific to the three chief OSs in use in information technology today, namely Microsoft Windows, Apple Mac OS X, and various distributions of Linux. We'll then take a look at specific applications that run on one or more of those aforementioned operating systems, and we'll look at how we can mediate against application compatibility there. And then finally we'll look at understanding system requirements. This is a particularly important topic for IT salespeople. You'll find as you work with IT professionals who work with installing software day in and day out that they can develop a jaded eye or some skepticism with regard to vendors' published system requirements. So that's some particularly important information for you. Let's get to work. First, let's examine Microsoft Windows. The latest and greatest version of the Windows desktop operating system is, of course, Windows 7. The version prior to Windows 7 was Windows Vista, which was largely a failure both in business and consumer environments. The chief reason that most industry experts give regarding the source of Windows Vista's failure was that Microsoft was so hot to rush this product to market that they distributed Vista far ahead of where other hardware vendors were in terms of their developing compatible software, drivers, and so forth. So we had individuals installing Vista in business and at home, and then finding they're unable to use their peripheral devices, they find that applications crash, etc. Microsoft has certainly learned from their mistakes, and the adoption of Windows 7 as of late 2010 is just outstanding. One issue that's relevant not only for Microsoft Windows OSs, but any operating system is this issue of 32 versus 64-bit code. Remember earlier in the course when we talked about motherboards and processors and their ability to generate either 32-bit long addresses or 64-bit long addresses. And I mentioned that the two chief benefits of having a 64-bit processor instead of a 32 is that you can, number one, address more than 4 gigabytes of RAM, which is the hard-coded memory limit for 32-bit processors. And that also with 64-bit operating systems we have much faster speed. You have more data lanes, so to speak, and you can transmit more bits per unit time than you can with a 32-bit environment. Now the way this works is backward compatible. That is to say, in most cases, that is to say Windows 7 64-bit, Mac OS X 64-bit, you can run most older 32-bit applications acceptably. Now I say acceptably because the 64-bit operating system generally needs to create an emulation layer or an emulation environment to sort of fool the 32-bit application into thinking that it's running on 32-bit hardware. So as you can imagine, that translation process introduces some overhead, so you can never expect a 32-bit application running on a 64-bit computer to run very well. Now, forward compatibility is absolutely out of the question. That is to say, if you have older 32-bit hardware and you try to install, say, Windows 7 64-bit, well, you're out of luck. It's just not going to happen. And that's pretty standard, really, with any application, not just with operating systems. With Windows, Microsoft has published an entire suite of application remediation tools in terms of how we can address the issue of upgrading our computer to the latest and greatest. Let's say we buy a new 64-bit computer and now we have Windows 7 and we have a, quote, legacy, as it's called, an older 32-bit application that we really want to run and want it to function well. Well, Windows 7 includes built-in compatibility modes that you can configure directly from within Windows, such that you can configure that application to run in, say, Windows XP mode. Again, tricking, in a sense, the application into thinking that it's running on a Windows XP 32-bit box instead of, say, a Windows 7 64-bit box. For IT administrators, you have what's called the Application Compatibility Toolkit. This is a free downloadable suite of tools that systems managers can use to generate application fixes for a large business enterprise environment. Windows XP mode is a feature that's optional in Windows 7. You can download it and use it for free from the Microsoft website if you have a legitimate version of Windows 7 installed. And this actually uses what's called virtualization technology to run your old Windows Windows XP applications in a real live Windows XP environment. So in a sense, in a very real way, you're running Windows 7 on your desktop computer, and then when you fire up your legacy application, it's actually running in a Windows XP sandbox. Very interesting technology. In Windows XP mode, again, there's an enterprise version of that IT administrators can use to manage this Windows XP mode across lots and lots of computers. You may actually, if you find this stuff interesting, want to take a look at the CBT Nugget series that I developed on Windows 7 deployment. The exam ID for that, the Microsoft Certification Exam ID, is 70-686. Check out the CBT Nuggets library and look at this if you're interested, because there's a ton of information out there, and if I do say so myself, some quality instruction on how to use these application remediation tools in business with Microsoft Windows application problems. Finally, any recent version of Windows, Windows Vista, Windows 7, has a built-in utility that comes on the product DVD, or alternatively you can download it for free from the Microsoft website called the Upgrade Advisor. This is definitely recommended to do if you have a piece of hardware running, say, Windows XP, and you're looking to do an in-place upgrade to Windows 7. There's the question of system requirements that we're going to discuss in detail a little bit later in this nugget. In other words, does this Windows XP machine have the minimum or suggested amount of processor, memory, hard disk, and network resources to support an installation of Windows 7? And as I'm going to tell you, I'm kind of letting the cat out of the bag here a little bit. You want to avoid the minimum requirements that Microsoft and other vendors give you. If your machine just barely meets those minimum requirements, then yes, it's technically feasible for that upgrade to complete, but dollars to donuts, your user experience in that new version of the operating system will be just awful. It'll be so slow, you'd probably have more fun watching paint dry. Therefore, the Upgrade Advisor is a tool that scans the computer, it's just a simple piece of software, and gives you a detailed report on the aspects of your computer, not just hardware subsystems like CPU, RAM, disk, and network, but will also scan all of your device drivers and installed applications and give you a detailed report as far as what will work and what won't work once you complete that upgrade. Really overlooked tool, but I've got to tell you, this will save you so much heartache if you're in a position to wanting to upgrade to a newer version of Microsoft Windows. Just to give us a little extra experience, I visited the Microsoft download site and looked up Windows 7 Upgrade Advisor and downloaded it. It's a very small download, just a few megabytes, and now we're running it now. You'll notice that the first page of the Upgrade Advisor for Windows 7 says to make sure to connect and turn on all of your devices. So this would be USB removable drives, connected printers, etc. You click Start Check, and it's running a compatibility check. This will take a few minutes. Alrighty, things always go faster when you're doing a nugget. You didn't have to sit through that like I did. Oh well, the Upgrade Advisor after several minutes completes its report. I am on a Windows XP Service Pack 3 based 64-bit Dell workstation computer, and you'll note that the report consists of both 32 and 64-bit sessions. Tells us that we're going to need to do a custom installation of either 64 or 32-bit Windows 7, and then we'll need to reinstall our program. In other words, it sounds like we're not going to qualify for a good in-place upgrade. Also, the scanner detected that I have Outlook Express installed. That makes sense. Internet Explorer 6 and Outlook Express 6 come standard with Windows XP, and it tells us that this is no longer included with Windows 7. Dell has a website that might give us more information. We can visit Dell's website. 4 system requirements passed. Tells me that my graphic adapter will allow the Windows Aero interface, my CPU meets the requirement, my RAM meets the requirement, and my hard disk space meets the requirement. There's even a link here for Windows XP mode if we do have need for that backward compatible technology. Now let's turn our attention to Apple's operating system, Mac OS X. As of this recording, the most recent version of Mac OS X operating system is version 10.6, aka Snow Leopard. Not sure how familiar you are with Macs. If you're doing IT sales in an academic environment, you're almost guaranteed to run across Macs. Alternatively, if you plan on selling to multimedia developers, multimedia video production shops, etc., you're very likely to see Macs there as well, so it's important that you familiarize yourself yourself with this operating system. Mac OS X in a nutshell runs exclusively on Apple hardware, of course, and it boasts some really neat features. It gives you the stability of the old Unix operating system that's been around since the 60s. In particular, Mac OS X at its kernel, at its deepest level, is built upon the free BSD distribution of Unix. So it's going to give you really good stability, really good protection. And then there's the graphical layer that runs on top of the BSD kernel that is just so pretty. Apple engineers are really good at prettifying the interface up. Anyway, what are some possible issues with application compatibility with Mac OS X? Well, number one, you should know that Mac OS X and Windows applications do not interoperate, just right off the bat. Now, Apple and Windows both support applications that have been written in the Java programming language. That's one really nice thing about Java, the fact that it's cross-platform. But other than that, you're either using Windows tools to develop Windows executable code, or you're using Apple's own Xcode toolkit to build Mac OS X applications. Regardless, you need to have the appropriate level of user rights to even install software on a Mac OS X system. And actually, this is global across late versions of Microsoft operating systems, specifically Vista and Windows 7, and all versions of Unix and Linux. By default, you have to be what's called a local administrator, or have full control over the entire system in order to install software. And that should make sense from a business perspective. If you're tasked with maintaining all of the workstations in your organization, think of what a potential management nightmare it is, what a support nightmare you have on your hands if users are allowed to install their own software. Then they'll be asking you for support on software that has no business relevance. They're likely to install malware and infect their computer. The list goes on and on. So know that user rights are important both with Apple and Windows, and heck, even Unix, Linux. Software update is another thing that's global to all operating systems. I'm just putting it here really for convenience. Software update is a utility included with any current OS that checks your system files, checks your operating system files, and even in some cases will look at first-party software and determine whether any updates are available. Generally speaking, it's a good idea to apply updates to improve the stability and security of the system and, of course, enhance compatibility. Now, we'll get into some Mac-specific compatibility techniques now. In the Apple developer world, they have an emulation layer called Rosetta. Remember I mentioned a few minutes ago that in Windows, there's plenty of things you can do to trick an application into thinking either A, that it's running on 32-bit hardware when it's actually running on 64, or B, the application is tricked into thinking that it's on an older version of Windows. Similarly, we have in the Apple world a couple different methods. Number one, you can do the same thing in terms of tricking an application into thinking that it's 32-bit instead of 64. That's done very easily in the Mac OS interface. And as far as the Rosetta emulation is concerned, this is even more significant yet. Without going into the history too much because it's not relevant, Apple in the early 21st century ported their Mac OS X operating system and all of their computers, their laptop computers, their desktop computers, their servers, from the Motorola PowerPC CPU to the Intel CPU. Now, that really was a huge advance because Intel is the common platform for, well, just about any OS nowadays, whereas previously PowerPC was a very specialized processor that you saw 9 times out of 10 just on Apple or potentially some other Unix-based workstation. With Intel, we have the ability to run Windows on a Mac. In fact, in Mac OS X, they include a piece of software called Boot Camp that does allow you to switch between an installation of Windows and your Mac OS X. It's really very nice. Now, the likelihood that you're going to try to run a really old piece of software, because Intel processors and Macs have been around for several years now, but for backward compatibility, this Rosetta software is built into Mac OS X such that, with some exceptions, you can take an old application that was written for the PowerPC chip and still run it on your new contemporary Mac. You would just enable Rosetta. Now again, performance is going to take a hit. Whenever you run a 64-bit hardware running a 32-bit program, you're going to get a slowdown. When you're translating processor instructions like this from PowerPC to Intel, obviously that's going to incur overhead. But for some users who just can't live without their legacy application, that presents a solution. By the way, most software developers now in 2010 are going to write their macOS applications specifically for Intel processors, but it's possible to use Apple's what's called Application Programming Interface, or API. This is a fancy acronym that refers to the rulebook that's published by hardware and software vendors that allow third-party software developers, or programmers if you want to use that other word, to build software for those systems. And in the Apple API, they allow developers to produce what's called a universal binary program. And this is a program that will run either on PowerPC or Intel processors. Very special case there, but I wanted to make you aware of it. Other Apple hardware that you're likely to see in business, iOS. This is the iPhone OS, also used on iPod Touch, and then the iPad Slate or tablet PC. Same issues apply with these guys as do with the Mac OS X operating system as a whole. They're all similar in as much as we want to look at things like software update, we want to look at network connectivity, Wi-Fi. We'll talk more about network troubleshooting again in just a moment. And then with respect to the iPhone and the iPad, these portable Mac devices, we have an application programming interface that enables developers to create universal apps. It used to be with iPhones you had the App Store, and it still is for that matter, where you can download for free or for money depending these really nice little apps that give you games, give you utilities, so on. Then when the iPad came along, there was the problem of, will the iPad allow you to run iPhone apps? Well, yes, but it looks pretty bad. It's not the best experience. So then software developers are faced with the question, do we just convert all of our iPhone apps to an iPad version to take advantage of all the additional screen real estate? And if we do that, do we now have to maintain two separate copies of the code, one copy for the iPhone and the other copy for the iPad? Fortunately, no. Apple has given us this universal app API such that we can create a single application, put it in the Apple Store, such that if it's installed on the iPad, you get the bigger display and all of those features. If you install it on the iPhone, you get the iPhone rendered version. Really smart decision on Apple's part. Finally, let's look at NICS issues. Now, you're wondering, what the heck does this mean here? If you go back before Microsoft Windows to MS-DOS, or if you've used Unix actually, you might have used the asterisk, also called the star, as a wildcard operator. Normally this is meant to denote many things. And what this means here is that the star could represent U for Unix or LI for Linux. A lot of times star NICS is used as a shorthand notation. Bottom line is Unix has been around since 1969. It was developed by AT&T in the Bell Laboratories. In the early 90s, a fellow named Linus Torvalds developed a variant of Unix based entirely on free and open source components. He called it Linux. Nowadays you'll find both used. Traditionally, Unix is used in older shops, Linux in newer. Linux has several distributions, and by the way, we'll just strictly look at Linux from here on in. Linux is a Unix-like operating system that behaves pretty much the same way. But Linux has been in the open source world for, as I said, I guess 20-something years now, a little under 20 years as of this recording. And you have Ubuntu Linux, which is a very popular desktop Linux version. You have a company out in Research Triangle Park, North Carolina called Red Hat. They have some business class and enterprise Linux distributions. You might think to yourself, well, Tim, didn't you just say that this was free and open source software? Open source, by the way, means that you can actually examine the underlying source code in the Linux operating system and make changes to it if you want to. That's very different from a closed source operating system like Microsoft Windows. The reason why organizations like Ubuntu and Red Hat do wind up charging money is that you're not paying the money, strictly speaking, for the software license. You're paying for support. This is particularly important, support is, if you decide to deploy a distribution of Linux in your organization. You absolutely want to have experts there to help you if you get into trouble. Traditionally, Unix and Linux have had very steep learning curves and never really had a solid adoption as desktop operating systems. They're just very nerdy, really. Ubuntu, if you were going to try a version of Linux just to get your sea legs, I would recommend you go with Ubuntu because that Linux distribution was built from the ground up with usability in mind. But still, there's no way around it. If you're going to use Linux, you're going to have to be familiar with the command line interface in addition to your traditional graphical user interface. To our point now, with compatibility issues, installing software on Linux is easier than it's ever been before, but still is not anywhere near as easy as it is in just downloading or purchasing the software media and then double-clicking to install. With Linux, you have the idea of software packages. These are where the compiled software components are put in a particular format. Now, it was more partitioned, such that if you had a .rpm software package, that was only going to really work on a Red Hat-based Linux system. If you had a .deb software package that you've downloaded, that's going to run on a Debian Linux box. Nowadays, you're pretty good as far as being able to open different package formats on any distribution of Linux. However, you may have to install, you guessed it, the appropriate handler for the appropriate package type. There's a tool called RPM, for instance, that's used to handle RPMs. Linux uses the Debian package format by default. There's other ones out there. Those are probably the two major ones, though. And what a lot of real, true blue Linux nerds like to do is compile software from source. Unix Linux is a different world, everybody, because this whole idea of the GPL, the GNU Public License, the open source license, also sometimes referred to as copyleft, as a tongue-in-cheek poke at copyright. What this means is, as I said earlier, you could get, for instance, let's say somebody creates a relational database management system that uses the SQL data access language, and they publish this under the GPL license. Now, I'm getting a little ahead of myself because we're going to talk about licensing in just a minute. But what the terms of the GPL mean is that we have access to the underlying source code, so we know exactly what makes this software tick. We received it for free from the owner of the project. Let's say we make some tweaks to suit our environment. We're good. Let's say we make some additional tweaks and add some new functionality and we think, wow, we've significantly improved this product. Now let's go ahead and offer this to other people to download, this modified version. Well, in order to obey the GPL, that's fine, but we're required to make that new upgraded, revamped product available with the source code so that folks who download it from us for free can also get into the source code and modify it. It's a really nice grassroots way to do software development, and one reason why Linux and Unix are considered such stable, powerful, and secure operating systems is because everyone in the community knows what the source code looks like. Therefore, if a vulnerability does crop up in a component that could allow malicious software to run, malicious users to access a computer inappropriately, because everybody in the community has access to the underlying source code, being able to identify first, and then fix those problems occurs very quickly in the Unix Linux world. By comparison, think of Microsoft Windows and all of the security vulnerabilities that it has every day. Because nobody is able to reverse engineer the compiled Microsoft Windows files and look at that underlying source code, it by definition is going to take longer for Microsoft themselves to identify and resolve those vulnerabilities than it would if the community at large, customer community and development community at large, were able to see the code. So there's really a push-pull between commercial software on one side and open source on the other. Software packages can be pain in the neck to install, there's no question about it. User rights are just as important in Unix Linux. You need to have administrative rights to install software on a Linux machine. Linux and Mac OS X both have this really nice sudo command, and this allows you to temporarily elevate your user rights so that you're logged on as a normal user normally. You run sudo prior to installing your software, ctia is another way to pronounce this. Of course, you'd have to have the password for an administrator account. Install the software as an administrator, and then you go back to being an ordinary user. Now, besides being easier on the system's administrators to have everyone in the organization running their computer as a normal user instead of as an administrator, there's also a security aspect. Let's say a user is logged onto his computer as an administrator, which unfortunately is the case more than you might think. It's almost always the case for home computer users and is the case too often, in my opinion, in business. If that user opens an email attachment and launches a Trojan horse program, malicious code in other words, that code is going to execute on the computer in the context of the currently logged on user. And if the user is logged on as an administrator, then that malicious code therefore has administrative access to the system. Not good. So we want to run as a standard user and elevate our credentialing only when necessary. A lot of people slammed Windows Vista with user account control such that every time you attempt to make an administrative action, the screen got dark and you'd see this elevation prompt or a consent dialog. That's called user account control, as I just said. And again, it's that idea of you want to be running as a standard user and you want to be aware of when an administrative action takes place such that you are the one who initiated that action and not some other process behind your back. The final Linux issue that comes up with compatibility, application compatibility, is the subject of dependencies. Not much is more frustrating, quite honestly, than going to install a piece of software on a Linux machine and repeatedly getting roadblocked because the installation gets a little bit in and then boom, it bails out saying you need such and so components installed. You download, you locate those components, you install them, restart the original installation, you go a bit further, bang, it bails out and you have more dependencies. That's referred to as dependency hell. And fortunately, current versions of Linux are much better at resolving these dependencies. But it used to be a huge headache and basically involved you doing a lot of reading and research prior to installing any application to make sure that all of your dependencies were met prior to you initiating the application install. Before we complete this nugget by examining, or should I say, re-examining network troubleshooting and then doing system requirements, I wanted to take us out onto the web briefly to take a look at some of the major technology vendors' support websites. Generally speaking, you can oftentimes guess at what the URL or web address for a vendor support site is. In the case of Microsoft, they have support.microsoft.com. In the case of Apple, it's apple.com/support. For Ubuntu Linux, ubuntu.com/support. The list goes on. Of course, Google or Bing search engines are your friend if you just want to do a search. The Microsoft support website is really, in my opinion, a model for how a technology vendor's support site should be. You'll notice that it's laid out in really easy-to-use language. We have a news section, a collection of recent downloads and updates, and then right here prominently in above the fold, as it's called in web design terminology, we have fix a technical problem, and we can visit the Microsoft Solution Center. So the idea here is if you're having a problem with Windows XP, you can type the name of the product here, or you can come down to their list. If you're having a compatibility issue with Word or Outlook or some piece of software, you can do that. Let's just say that our problem is with Windows XP. We can see top issues. You can do a search. It's a really excellent website that you should be aware of, even as an IT sales representative. The Apple support site, similarly, is really good as well. Now, Apple is a little bit different from other original equipment manufacturers inasmuch as they have strict control over their hardware. In other words, the Mac OS X operating system, at least the desktop version, is allowed to run only on Apple computers. Now, there are folks called Hackintosh individuals who are committed to making Mac OS X run on, say, a Dell workstation. But Apple doesn't like that for obvious reasons. So what you find at the Apple support site is a collection of, well, you can download all of the product manuals for any Mac hardware that you own. In fact, here it is right here. We have manuals, tech specs, communities. The communities is particularly important. Besides going to the vendor's own website in particular their support subsite, you'll also want to take a look at popular discussion forums. If you're not familiar with these, discussion forums are threaded discussions that folks in the world participate in to post their questions and get answers not only from other users, but sometimes the vendor themselves will assign employees to answer customers' questions. So this can often save you some troubleshooting time by checking out discussion forums. Microsoft has discussion forums, Apple does. Certainly Linux has tons of popular discussion forums. Most or all of them are free. One notable exception is the website Experts Exchange. They used to be really, really great. However, well, they're still great. I shouldn't inject bias into this discussion, but they saw a money model to be made, and now to really get the most out of the expertsexchange.com site, you have to pay a subscription fee. What you're seeing here is a typical discussion thread in the Apple support forums where an individual says that he or she updated their iMac the other day and now they have a problem, and then you have other people chiming in. Now this does take a steady hand, a steady mind, and some patience, because you'll often find noise in these discussion threads and suggestions that just aren't worthwhile. So in many cases I tend to scroll to the most recent updates to see if something someone said actually worked. As I said, Linux, because it's an open source operating system, you'll find that support for those systems and open source applications tends to be really, really robust. This is the Ubuntu support site, all set up about the same. Here you can get documentation, technical answers, and then remember I said that certain distributors of their own customized versions of Linux have a business model such that you can pay them to provide professional support services. And again, this is something that probably not Joe or Jane home user would use, because quite honestly, Joe or Jane home user dollars to donuts is running Microsoft Windows or Mac OS X. But absolutely, if you're an IT administrator in business who are considering running Linux on some of your servers and potentially even some of your desktop computers, going for a paid service contract would be a good idea. Also, to tie in what we learned in the previous nugget with hardware compatibility, I forgot to tell you about this website. This is a long-standing website that Microsoft has published called the Windows Hardware Compatibility List. And this is a really important site for IT administrators to know about, because what you can do here, as you see, choose your operating system and then take a look at the list of hardware products that have passed the Microsoft Windows compatibility tests. So what this does is enable you as an IT manager to get some certainty prior to spending potentially thousands, tens of thousands, hundreds of thousands, or millions of dollars on new hardware to ensure that the hardware that's included in that system is going to be compatible with Windows 7. So if we were in the business of producing peripheral cards, for instance, what if let me go to hardware here, what if we produced video cards? Like the ATI company. They have a line of video cards called Radeon. We would definitely want to download those rules, those hardware compatibility test rules, from Microsoft and demonstrate to Microsoft that our hardware and its associated driver are compatible. And what Microsoft will give us is the license to use this compatible with Windows 7 seal that we would then affix on our website, and certainly we would put this seal on the boxes such that someone shopping around for a video card can look on the box, see that this is guaranteed compatible with Windows 7, and you're off to the races. Now we'll turn our attention again to networking, this time looking again specifically at compatibility issues that pertain to networking. First, remember what a networking protocol is. The layperson's definition of a networking protocol would be a networking language that systems speak. Again, I hate the personalization, or the personification I should say, but sometimes that's the best way to describe these tech things, such that two or more computers can meaningfully exchange data. Specifically and technically, a protocol is a set of rules. In other words, a method or series of methods to package data such that the data can be sent and received accurately and reliably. I mentioned that the default protocol in use nowadays, not only for local area networks, but for internet communications, is the TCP/IP stack. And so we have the notion of distributing and maintaining these IP addresses for every system that will participate in that network. If you have two systems with incompatible IP addresses, or if you don't have connectivity devices like routers that can get those data packets from one host to the next, you're going to run into problems. The subject of TCP/IP is huge and vast. We just need to touch the very top of it for our exam success. We talked about protocol negotiation in an earlier nugget, specifically the notion of half duplex versus full duplex and link speeds that need to be compatible to get those data packets down the highway, so to speak. And then finally, this is an important consideration, firewall blockage. Remember earlier we defined a firewall as hardware and/or software that's used to filter traffic to or from a network. Well, that's definitely true. Any company worth its salt is going to need to have a dedicated firewall device at the perimeter or edge of their local area network. Nowadays, though, ever since Windows XP Service Pack 2, Windows systems have shipped with a software firewall built into the OS. Similarly, both Linux and Mac OS X also have built-in software firewalls. So therefore, you might have a network in which all of your Windows systems have their own, they don't have their own private Idaho, they have their own private firewall. And then what if you decide to bring up a line of business or LOB application on one of your servers? And let's say that line of business application communicates on a specific port number. You'll find out of the box probably that communication is denied or prevented between all of your hosts on the network, all of the client machines, and the line of business application. Well, why is that? That's just simply the firewall doing its job on each of those client machines. It sees an unfamiliar connection on an unfamiliar port number, so it's going to deny. As an enterprise administrator, it's your task to make sure that everybody's firewall, some administrators just say bollocks the whole thing and they'll disable firewall on everybody's computer, trusting the perimeter firewall will do a fine job at protecting the network. Other administrators, such as myself, will leave those firewalls enabled, but will create what are called exceptions or rules that enable that line of business traffic. But this again is a whole other issue, and it's a day-to-day issue for systems administrators. Other networking incompatibilities would be interference. This could be wireless interference, as we discussed earlier in this series, and also interference in your plenum space. Remember I mentioned that your wired Ethernet, you wind up aggregating connections, let's say per office or per room, and then running those cable braids above a drop ceiling and between walls. Well, what's going on in that drop ceiling? Do you have metal airflow ducts that could be producing interference? Do you have other devices in a wireless environment that operate on the same frequency as your WLAN? These need to be taken into consideration and preemptively fixed. As far as tracing network connectivity issues, like let's say a user just can't get online in your corporate office. So you visit his or her computer, sure enough, they just can't get on the network. Let's say you replace their Ethernet cable that connects their desktop computer to the wall port. Still, they can't connect. The next thing you're going to want to do is go to the end of the hall to the telco closet. You remember those from the previous nugget. And ensure that there's continuity on the cable that connects that user's Ethernet wall drop to the switch and patch panel on that telco closet. A tool that's commonly used for this is called a toner and probe, sometimes called a fox and a hound, the fox and the hound. Now what the heck do I mean by that? Here's an amplifier probe. The way this works is as follows. You've got one side of the equation here where normally this one doesn't have an RJ45 plug, but if you're using a toner and probe designed for wired Ethernet, you would have a short segment of Ethernet cable here, and you'd plug this into the user's Ethernet drop in their office. You'd then go down to the patch panel and you'd use this guy to rub around. Literally, you take this probe, here's the toner and here's the probe. You probe the RJ45 port on the other side. Now you use this a lot of times when you have a poorly documented local area network. Remember I gave you the situation before where you might not have marked which drop corresponds to which jack on the patch panel or switch. So you can literally go through unplugging and then sticking the probe in the RJ45 hole, and once you hear a tone, that lets you know that's the port that's connected to the other side in the office. That can be an awfully time-consuming thing, tracing. Once you've traced and established which drop corresponds to which patch panel, you can use other network testing equipment to test for shorts in the cable, in the wall, or in the plenum space. You can test for other issues that might be there. Maybe the cable is kinked, it's suffering interference. In worst case scenario, you might have to pull and replace that cable through the plenum space. A protocol analyzer is used not so much for hardware like cabling, but used to troubleshoot networking issues on a packet-by-packet basis. You can use protocol analyzer software to literally visualize the traffic that's going through your local area network medium. You can do protocol analysis for both wired and wireless networks, and it gives you a really good idea as a network administrator. It's called characterizing the traffic, to see where you have bottlenecks, to see if you have more than what should be there as far as one type of network traffic. Very important troubleshooting skill for the network engineer to have. We'll complete this nugget by briefly examining system requirements. Any software vendor worth its salt is going to include in its documentation a list of suggested and minimum system requirements. This refers to the hardware that needs to be present at minimum on that system in order to run the software. You'll find this always with operating systems, but you'll also find system requirements for productivity software, for instance Microsoft Office, and for the consumer user, folks who are into playing games will often pay close attention to those system requirements, because particularly with contemporary games, there's not much that's more frustrating than playing a game that has a really choppy frame rate. Now, some software vendors get a little jiggy with their wording, and I don't really like this. They'll just give you the system requirements that are the bare minimum to run that software. And as I stated before, that's not optimum, because we want to have a decent user experience with that software. Better software companies that are more transparent will provide the bare minimum and also recommended requirements. And you'll always want to go more toward this number, or this collection of numbers, I should say, than the minimum requirements. Let's pop out onto the web. This is the Microsoft Windows 7 Systems Requirements page. And they've used, by they I mean Microsoft, used some pretty good language, I think. They try to tone down the language so that not just tech geeks like you and me, but also lay people can understand this stuff. Says if you want to run Windows 7 on your PC, here's what it takes. So these would be the minimum requirements. And then they give you additional requirements to use certain features. So some games or programs might require a graphics card that supports at least Microsoft DirectX 10, etc. Windows Vista system requirements, same deal. Here's the absolute bare minimum. This is interesting. The bare minimum requirements, and then these would be the recommended requirements. Let me go back to the other one. Interesting. The Windows 7 does not give you explicitly a minimum requirements list, but the Vista one does. That's food for thought. We talked earlier about administrative rights that typically, and as it should be, whether it's in Windows User Account Control or Mac OS X Elevation or Linux Elevation, that standard users are not allowed to install software. You have to be an administrator. We've also talked about the Microsoft Hardware Compatibility List database, and then the importance of firewalls and how they can sometimes conflict with software installation. Resolving software compatibility issues review. Boy, we covered a lot of ground in this nugget, didn't we? Some of it was review, but some of it was brand new information. We looked first at OS issues. We looked at Microsoft Windows, Apple Mac OS X, as well as Unix Linux. I hope you have a nice holistic idea of how to resolve compatibility issues globally, regardless of the operating system, and then specific ideas for specific OS platforms. We then spent time looking at application compatibility issues. In fact, we kind of tied these two bullet points together, really. What's not in this list that I'll inject now was our brief consideration of network incompatibilities and resolving those. And then we looked at this, again, very important subject, understanding the importance and role of published system requirements for software. I hope that this has been informative for you, and I'd like to thank you for viewing.